Hey, thank y'all for joining us. My name is Johnny. We have Joseph and Jared. Today we're going to be talking about probability, expected value, and experimental value, and then we'll also show um, theoretical. Theoretical and experimental go together. And then Joseph will be doing expected value, and I will be going over odds. And we'll start out with Jared talking about expected, not expected, but experimental and theoretical value. I mean, probability.
All right. Thank you so much. Well, before we get to that, I want to start off by asking, what exactly is probability? Well, the best way to explain it can be shown here, as probability is just simply the number of outcomes that favor whatever event you want to win over all the possible things that can happen in that event. This is represented in a fraction and can be represented from 0 to 1. Now, if it has an odds of 0, there's no way you're going to win it. While if it has odds of 1, you are going to be guaranteed a victory. And then you have everything else in between indicates your chances of succeeding. Now, some of the most now for a theoretical event, the best way to describe it is just simply the odds of an event based on what you know about that situation. Like, for example, with a coin toss, you have two sides, heads and tails. That means, by logic, that you should have a 1 in 2 chance of winning the coin toss, whether you call heads or tails, which is about a 50% chance. And it also works with dice rolling, as you have a 1 in 6 chance of landing on a number between 1 through 6 on a fair die. Now, empirical probability, also basically is the odds of something happening based on however many times you do something. This completely rules out the theoretical probability because now you've done experiments with it. Because of that, you have data that tells you the odds of something happening a certain number of times in a row. Now, remember when I was talking about rolling a die and flipping a coin? Well, we can test that theory. If you follow along with me, we can roll 2 dice, say number of times. Let's say, what are the odds again? Can we get a double? Let's do it about 5 times. Once? Nope. In this case, out of the 5 times we attempted to roll 2 dice, we did not get anything with both dice being the same number. So with empirical probability, we would say that based on our experiment, you have a 0% chance of getting 2 dice having the same number based on the data we gathered from our experiment. Coin toss, same thing. Let's say we flip it 3 times. First time we get heads, tails, and heads. So in this case, you get heads 2 times and tails 1 time. So based on that, empirical probability suggests that you have a 67% chance of getting heads and a 33% chance of getting tails. So that's the best way to explain the difference between theoretical probability and experimental probability. With theoretical probability, it's basically what or chances based on what you know about the situation, and empirical is data that explains your chances. Now, another way this can be differentiated is by looking at the relationship between permutations and combinations. Permutations pretty much explains the odds of picking. Imagine yourself picking from a pool of tennis balls and there are 50 of them. So basically, it explains the odds of picking any sort of set of them, like 3 in a row or something, without regards to repeating in different orders. But with combinations, this takes away the repeated sets. It basically ensures that you get only 1 set of tennis ball of your drawings accounted for. I think the best way to demonstrate this is with a problem. So let's think about the lottery. Let's say you want to play the lottery and There are once again 50 balls, and you get to pick 5. What are the odds of winning the grand prize? First, we want to start off by looking for all your possible choices. So we'll start by calculating the permutations. This comes out to the equation of 50 times 49 times 48 times 47 times 46. And we have our answer right over here. Now, with that in mind, we want to use the concept of combinations, and we want to get rid of all the possible choices where the same set of 5 balls can be chosen but are repeated. But if they're repeated, we're going to get rid of that to ensure that each set of 5 balls can possibly be represented only once. So to do that, we'll divide our answer for the permutations by this equation right over here, which represents the number of balls you get to pick. The number of balls, or whatever, however many you can pick. So you start off by picking 5, then you only get to pick 4, then 3, then 2, then 1. That comes out to odds of 254 million plus over 120, which when simplified gives you your probability of winning, which is 1 in 2,118,760. That is not a good probability. I would suggest avoiding that lottery. Finally, let's try and assess, can this be useful in the world? I would say yes, but not in the way you might expect. With probability, I think the best way to look at it is if you can explain something to someone. Like with the lottery, you want to tell someone, hey, I know it's cool and all to say that you're in a grand drawing for fun, but don't bank on it. Don't make it your life, because your chances are you're probably going to waste away your life trying to go crazy on winning a jackpot. So if you can explain the odds of something happening to someone, it could possibly help them understand what to do in their life. Thank you so much. And now I'm going to turn it over to Joseph.
Thank you, Jared.
You're welcome.
So this is Joseph, and can you pull the PowerPoint back up?
Oh yeah, sure.
Thank you.
You're welcome.
So I'm doing expected value, which is like what Jared just did, also a formula-based operation. So we'll see in just a minute. There we go. Okay.
All right, Joseph, hold on a second. Let's try something. Can you control the screen?
Yes.
All right.
There we go. So the vocabulary for this is pretty simple. It's just expected value, outcome, and probability. But those are all the terms we're going to need. So the definition of expected value is basically outcome versus probability. So for example, as we'll see in a minute, let's say you have a pie chart that has, just for an example, 10 like different sections on it. It's like slices of the pie. What would your probability be of getting any one of those? If they were all the same size, it would of course be 1 in 10. And that's how you can list this, is with outcome versus probability. So to give an example of that, here we go. So in this case, we have I guess it's like a lottery thing because it's money. We have a quarter of this circle is made up of something labeled $1,000, $4,000, $10,000, $500, $2,000, and $300. So the outcomes are the numbers that are listed of, like, outcomes are basically what could you get? Like, those are all the potential outcomes. So we just list those up there. The probability is our chance of getting each one. So for example, 300 looks like about 1/8 of the circle. So we have about a 1/8 chance of getting $300. That's how we just list the outcomes versus the probabilities. Then we're ready to plug it into the formula, which is E of X equals Then we multiply each of these outcomes by their given probability. So 300 times 1/8, and we add all those together. So plus $500 times 1/4. Then we should start by multiplying these to 37.5, and then finally add all those together, and the answer and the average that we can expect to is what we can expect to win. So expect to win on average around $2,412.50. This looks like a pretty good form of lottery, whatever it is. So that pretty much covers it for this one. So I'm going to turn it over to Johnny Scott.
Oh, I'm sorry.
All right, guys. Hey. Awesome. So my part of this presentation, I will be going over odds. Odds they pretty much correlate with the experimental value, the different ones that Joseph went over with, experimental value, and it's pretty simple to understand. So I hope that you will learn from what I'm about to tell you about. So what are odds? Odds are defined as the probability that an event will occur divided by the probability that an event will not occur. And there are two different kinds of odds that we're going to go over. We have the odds in favor and the odds against. The odds in favor, this is represented by the chances of something positive happening over what you do not want to happen. And the odds against is represented by the chances of something negative or something that you don't want to happen over something good. These are different things to remember that I believe would help you out a lot. When you're using odds, remember that both numbers should equal the total amount of the subject that you're working with. Now you may think, hey, how does this make sense right now? But remember these, because as I show you different examples, you will see how they all work out. But essentially, like, if you remember that when Joseph was presenting, not Joseph, Jared, when Jared was talking, it was like, had the fractions and everything like that. Well, odds, let's say we have a 1. Well, guys, looks like this isn't letting me write this time. Let's see. Well, I'll just show you on the next slide, because that's not going to let me write this time. I was hoping that it would work, but it's not working right now, so I'm sorry for that. But, and on the left side of the ratio is what you want to happen, whether it is a failure or a success, good or bad. And then on the right goes what is left over, or the remainder from the whole number that you are working with. Now, over here we have probability to odds. This just shows you how probability is connected with odds. And if you wanted to use them vice versa or whatever, you can do that. Now, over here it shows that we have probability 5/13. This is like, let's say you want to pick something at random, you have 5 out of 13 chances of getting it, or you picked it. Like if we used experimental value, this is what you got. You picked it 5 out of 13 times. Let's say we're going to roll dice. You roll a dice, you're like, how many times can I get 1 out of rolling it 13 times? The experimental value is what you actually did. So I rolled the dice 13 times, and I got the 1 5 times. And you have 5, which is how many times you got it, over the total number. Now, if you want to do the odds, you have the 5, you roll the 1 5 times. And then to get to 13, you have to add 8. 8 is what's left over, or the unfavorable outcome. So 5 times I got the 1. And then 8 is how many times I did not get what I wanted. Now, if you wanted to come over here and just move odds over to probability, you can see as in these two odd numbers, the odds, and yes, they are odd numbers, ironically. But this 9 to 21, that's the odds that, let's say, we would get 1. So we would get 1 9 times, and we would get another number 21 times. So you add both of these numbers up right here, and you get 30. That's the total number of outcomes. So we rolled the dice 30 times. We got the 1 9, and then we did not get 1 21 times. So now, over here, if you would, on your own time, just like for extra work, homework or whatnot, or just for practice, just grab some dice from a table or wherever you have your dice set, and then I want you to roll the dice 20 times. Keep track of how many times you roll the dice, like 20 times. And I want you to keep track of each number that you get. 1 to 6 are the options. And then we'll transfer the data to the table provided below. And then we'll find the odds for and against rolling each number. So, as you can see, I have a bunch of numbers written up there. To save time, I went ahead and I wrote these numbers up here, right there. And these are what group 1, which group 1 would essentially be myself, Joseph, and Jared. What we have is we got 3, 2, 5, 1, 4, 4, 5, and so on, as you can see. These are the numbers that we got when we rolled the dice each time. We kept track of it. Now, what we're going to do is we're going to try to write it on here, but I don't think that I'll be able to. I can try it again. If it'll work, great. If not, I'll just go to raw. I'll have to type it in, and we can work with it that way. Awesome. I can write in here. Okay. So now we have numbers rolled down here. These are the groups in the vertical column, and then in the horizontal column, these are the numbers that we rolled. So group 1, which is my group, 1. How many times did we get a 1? If you look through here and count, you can see we have ones. We have 1, 2, 3, 4. So we have 4. We have 4 ones. Boom. 4 ones. And then you have to remember, for the odds, we're going to keep track of how many we need to get to 20, because 20 is the total number that we're working with, okay? So the odds for getting this, the odds for getting a 1 would be 1 to 16. And why is the number on the right 16? Because 4 plus 16 equals 20. Or you can do 20 minus 4, 20 minus the number that you were trying to get, which ones. We got 4 ones. So that's why we have the 4 on the left side. And then we need to get to 20. So 20 minus 4 equals 16. And that's why we have 16 on this side. Now, the odds against, these are going to be the ones for. And then we have odds against. And I'm just going to use the A for against, okay? Now, for against, we would just simply just flip it. Flip it, and then you would have 16. That's a 16. And then 16 to 4. 16 to 4 odds of not getting a 1. Now, for 2, we would do the same thing. I've already worked all these out. So for this one, for against, or for 4, we'll start with 4. 2, we got 2 4 times. 4 times. Boom. And then let's skip over to 3. We got 3 4 times as well. And then 4, we got 3 times. 5, we also got 3 times. And then 6, we only got 2 times. So now, for 4, remember, we need all these numbers in each column to equal both numbers on the left and right to equal 20. So 20 minus 4 would give us the leftover or the remainder. So this one, same as the first one, 16. Let's come over to 3. It's going to be the same as the one before, 16. Now we want to come over here to 4. What is 20 minus 3? 20 minus 3 is 17. So we have 3 and 17 odds, because we will not get 4 17 times. We did not get 4 17 times. And this one over here, this will be the same thing for the same reason, except this is a 5, not a 4. So we have 3, 17 odds. Now for 6 over here, we have, was 20 minus 2, 18. We have 2 and 18 odds. Now, for against, simply we're just going to flip all of these, okay? Flip them. Boom. We have 16, dot, dot, colon. 40. Boom, right there. Okay? And this one will be the same thing. That'll be the same thing. Then over here, you would just flip this one. We have 17 and 3. And then come down here to the very end, and you have 18 and 2 odds for not getting a 6. Now, this is where it kind of will work like a fraction. If your teacher wants you to reduce these, you can. As you notice in the first one, we have 4 and 16 odds. If you notice, 4 is a multiple of 16. 4 times 4 will equal 16. So if we divide each number by 4, you will have a 1 in 4 chances of getting a 1, which will go for the same for 2 and 3. Now these, you can't divide those at all. Those are fine like they are, 3 and 17. Now down here on the very end with 6, this one you can reduce it also. Divide each by 2, you have a 1 in 9 chance. 1 in 9 chance of getting 6. Now this is when we roll dice, it's kind of like the experimental one because we actually did this. This is what we actually did. Now, if you want, please go home, try to do this with cards. I don't want to take up any more of your time because I feel like this is something that you'll be able to go home and do on your own. But the first one right here, as you know, 52 cards total. And we have 4 different suits. 4 different suits of cards. We have diamonds, hearts, clubs, and spades. 4 different suits. So what I want you to keep in mind is when you're looking for a heart, that means any of the hearts, okay? 52 cards total. Since we have 4 different suits, you would do 52 divided by 4, which will give you 13. 13 is the total number that we would be working with for number 1, okay? So if we were trying to find the probability of finding a heart, we would have a 13 in 52 chance because there's 13 hearts and 52 cards total. But what I am showing you is the odds. So for finding the odds, we have 13 for what we want to happen, for what we want to find. And then if you do 52 minus 13, you will get the answer of 39, okay? And I hope that this all makes sense. 13 and 39 are the odds for randomly selecting a heart from a deck of 52 cards. And remember, a heart is 1/4 of a deck because of 4 different suits. And then a red, remember, half the cards are red. So you would essentially go the same thing. And then for a 7, there are 4 different 7s. Now down here, you see it says a 7 or a queen. Now there's 4 different 7s, 4 different queens. So that's something important to remember. So this one would essentially be 8 cards possible that you could draw out of 52, okay? Now, when you see the and, this is a 7 and a heart. It has to be a 7 and it has to be a heart. So that is something also important. You have to notice that here there's an or, and then here there's an and right here. Boom. So 7 and a heart. That's only 1 card. So if you're doing probability, you have a 1 in 52 chance for number 7. And then if you were to do odds, you have a 1 in 51 chance of selecting that 1 card. Now for extra, if you just feel crazy about doing these, and you're like, man, I'm really good at this, go to school. I want you to go to your class. Look in the class, and I want you to randomly select a girl in your class. Find the odds of randomly selecting. So to do that, you would just count however many people are in your class, and then however many girls are, you put that on the left. And then essentially however many boys are, you put that on the right. That is something simple because you're working with 2 different factors, but a person is either a boy or a girl. Either or. And if you want to select a girl, boom, all the girls are on this side, all the boys are on that side, and then you put a semicolon right in the middle. And then that's how you do that. And then probability, don't forget that if you want to randomly select a girl, that you put all the girls on top of the fraction, and then you put the total amount of people in the class on the bottom of the fraction. That's all that we have for you. My name is Johnny Scott. My partners are Joseph and Jared. Thank you for listening, and I hope you had a good time.